Okay, Math 1 1.5, infinite and no solution notes. So this is going to work just like what we've been doing on our notes, except we're going to have two special case scenarios. The special cases are going to be infinite and no solutions. So we'll start off talking about infinite. You could also abbreviate this by that, like the infinity symbol. And you're going to put solutions afterwards. And solutions can also be abbreviated. So either of these you could write. Infinite solution is going to happen anytime you have an equation where you find some kind of answer. Towards the end of the problem, you end up getting like x equals x, or you get 1 equals 1, or you get 5 equals 5, or you get 10 equals 10, right? We're talking about anytime you get something that says they're equal, that is always true. It's like, well, yeah, come on now, this is true. You, there's no solving after it, but you don't get your variable equals a number, right? You get something that's true all the time that you could have told yourself before the problem even started. So if you end up solving a problem and you end up getting like 5 equals 5 or x equals x, you say, well, this is an infinite solution. You don't say x equals 0 or x equals 10, you say infinite solution. And on the other hand, no solution happens if you find something where it says like 5 equals 6, or 5 equals 5.5, or 10 equals 20, right? Anytime you find something that just doesn't make sense, it's not right, it's never right, it couldn't be right. That's whenever you know that you have a no solution, okay? So we have infinite. Infinite is whenever it always works. No solution is whenever it never works. It doesn't make sense. So let's look at number 1, or I guess it's number 2. We can, on the left here, we can combine like terms. You got a 3x and a 3x. Well, 3 minus 3 is 0, so we could say 0x. 0x equals negative 3. But this would be the same thing as saying 0 equals negative 3, right? If you have 0x, that's just 0. 0 does not equal negative 3. It never has and it never will. So if we look back up top, we look, well, where is it that we have something that doesn't make sense? The ones that don't make sense are the no solutions. So this is going to be no solution. Okay? Number 3. Again, we have two x's on the left here. Since they have the same coefficient, since both of them have a coefficient of 1, they can cancel. So we're going to have 1 equals 6. Well, and you say, well, Mr. Carrington, you're an idiot. 1 does not equal 6. That means that we've got a no solution answer. Okay? Anytime you're working a problem and you find that you have something equals something and it's not true, you're going to have a no solution. All right, number 4. Just like in number 3, look at that. We've got two variables on the right, two m's. Both of them have a coefficient of 1. We have positive 1 and negative 1. They're going to cancel. So on the left, we've got negative 6 equals. On the right, the m's cancel, and we're left with just negative 6. So negative 6 equals negative 6. That is true. That is always true. You could have told me that before we even started the problem. This is an infinite solution. All right, and just to show you what I mean, or just to show you a little example, say we said m equals 20. Then negative 6 equals, let's plug this 20 into this equation. We have m 20 minus 6 minus 20. If you add this up on the right side, you end up getting negative 6. So you get negative 6 equals negative 6. Okay. You could have picked anything. You didn't have to pick 20. You could pick 25. You could pick 3. You could pick 3,000. You'll always end up getting this -6 equals -6, or you might get like 0 equals 0. It will be true all the time, no matter what you choose. All right, sorry, somebody came in. So number 4, we've gotten that one done. Number 5. Number 5, we're going to start off by distributing this -5 to both of these guys. So we've got 3a minus 24 equals, we've got -5 times -2, that gives me 10. Positive 10, right? Because we got negative and negative. Then we have an a. Then we have -5 times -2 again, which gives me another positive 10. And then we have plus 1 at the end, right? So this highlighted thing turned into that highlighted thing. So let's combine like terms on the right side. We've got a 10 and a 1 that can go together. So we've got 3a minus 24 equals 10a plus 11. Okay? So now we get to decide which side do we want our a's on? What side do we want our variable on? So whenever I decide in my head, I try to think about which side has the bigger coefficient, right? So what I'm wanting is I want it to have a positive a. That to me makes the problem just a tad bit easier. You can do whichever way you want. It really doesn't make any difference. But in this case, because I have a 10 on the right, here's our 10, and here's our 3, I'm going to choose to put the a's on the right. So I'm going to subtract 3a from both sides. So on the left, I've got -24 equals 10 minus 3 is 7a plus 11. I can subtract 11 from both sides, and I get -35 equals 7a. I divide by 7. My 7's on the right cancel. I'm left with -6 equals a. Now, is this one of those special case scenarios? No. We have a variable equals a number. Almost all the problems that you do like this will end up having this kind of normal answer, like what we've been doing in the other lessons. We'll have the variable equals a number. It'll only be special cases, and it won't happen nearly as often where you have infinite or no solution. Number 6, we've got 5x plus 12 equals negative. This negative, we'll put a 1 right there. -1. -1 times 2x minus 5. Okay? And what we're going to do now is we're going to distribute that -1. Okay? You can distribute the negative, and it works just the same way, but I kind of try to distribute the -1 and kind of think about it like that. If you do decide to just distribute the negative, what you are doing is distributing a -1. I mean, it's doing the same thing, just a little bit. It looks different, but it's the same thing. So we got 5x plus 12 equals -1 times 2 is -2, and then we have x. -1 times -5 is +5. So now I'm going to decide where I want to put my x's. I kind of really quick in my head, I think, well, I've got a -2 and I have a 5. If I put them all with the 5, it'll be positive. So that's what I'm going to do. I'm going to add 2x to both sides. The ones on the right cancel. And again, deciding where you want to put your variable, it doesn't matter. If you want to always put the variable on the left, that works. If you want to always put it on the right, that works. It doesn't matter which one you choose. The answer at the end will be the same. So we got 5 plus 2 is 7x. And then we have plus 12 equals 5. We can subtract 12 from both sides. We get 7x equals -7. We divide by 7 on both sides, and x equals -1. All right, there we are. And again, this is a normal answer. It doesn't have anything special about it. It's just a variable equals a number. Okay, number 7. I'm going to start off by, again, distributing this -1 that's hanging out front. So I'm going to have -8 minus 7p, and then equals -7p minus 15. All right, now deciding where your variable is going to go. Now right here, I'm like, well, I've got a negative 7p on the left, negative 7p on the right. I'm like, well, that's kind of odd. Why don't I just add 7p to both sides? Okay, they both cancel, and I'm left with negative 8 equals negative 15. Well, that doesn't make sense. So I might go back and I might look at my work again and see, no, I haven't messed up. This is going to be a special case. This is where no solution, right? Because negative 8 does not equal negative 15, and it never will, never has. So we have no solution. Okay? Numero 8. I'm going to start off by distributing that 11. 11 times 12 is something. Oops, I don't know how it got over there. 11 times 12 is 132. Minus 11 times 3 is 33. 6 times 5 is 30, so negative 30x. Oops, I lost my equal sign there. I got ahead of myself. We've got this equal sign. Then I've got negative 6 times 5 is negative 30x. And then negative 6 times negative 11 is going to give me positive 66. All right, now deciding where I want to put my variable. I've got a negative 33 on the left, a negative 30 on the right. You might not see right away, but it's going to give you a positive on the right if you put the variable on the right. Again, it doesn't matter where you put it. Whenever I add 33 to both sides, they cancel on the left. I'm left with 132 equals 3x plus 66. I'm going to subtract 66 from both sides. On the right, they cancel. And on the left, I'm left with, we've got 132 minus 66. And I'm left with 66. 66 equals 3x. I divide everything by 3. And I am left with, here, can I do it this way? Divide by 3. I got 22. Okay. Now again, this isn't one of those special cases. This is just a cut and dry. There's our answer. Alrighty, number 9. We have negative 3 times negative 9, which is going to be 27, right? Yeah, 27. Positive, because we've got two negatives. And then negative 3 times negative 5 is going to give me positive 15x. Got my equal sign. I have a 9. And then I need to distribute this 8. I've got 8x minus, I don't know what that's going to be. What is that? 8 times 3? There we are, 24. Negative 24. For starters, I'm going to combine like terms on the right. We can see that I can put this 9 and this 24 together. So I'm going to just rewrite the left. 27 plus 15x equals, I've got 9 minus 24. Oops, that's 34. 24. That gives me negative 15 plus 8x. Now, if we look here, we can decide where we want to put our x's. I'm going to put my x's on the left, so I'm going to subtract the 8x and put it on the left. The right side cancels. The left, now I'm going to have 27 plus 15 minus 8, I'm thinking is 6, right? 8, 9, 10, 11, 12, 13, 14, 15, 5, that's 7. Oops. 7x equals negative 15. I can subtract 27 from both sides. The left side cancels, and I'm left with 7x equals, what's that going to be? Negative 42. That's a negative 42. I forgot the negative sign. I can divide both sides by 7. The left side cancels, and I've got x equals, what is that, negative 6, negative 6. There's our answer. And again, this is just cut and dry. So just a reminder, They will not always be no solution or infinite solution. A lot of them won't be. But you just need to keep that in mind. Whenever something doesn't make sense, it's probably going to be one of those two. All right.